Okay, George Washington, I believe you're up next. Getting to, I don't have to actually be introduced anymore. I'm getting to know all of you guys pretty well. And I really, to tell you the truth, I don't have a whole heck of a lot of questions for you because I've had a chance to view your podium pitch. I've read your material pretty carefully. I've also saw your presentation yesterday on the payload. All of that is really nice work. I guess really I'd like to focus a little bit more, maybe kind of on the lessons learned kind of aspects of things. If I'm looking at, what the key drivers are for the scores, then the way the scoring works, it's around, a lot of it's around innovation, and you've done an awful lot of innovation in your payload design. But a lot of it also is around, how robust is the rocket, and how robust has your testing been, and things along those lines. So I'd like to kind of explore a little bit of that with you, right? So you've had, for example, some flight failures, right? And that have kind of caused a kind of a bump in the road. I'm wondering what the kind of the key takeaways were from you in those failures, and how that translates into maybe a different way of doing your engineering process or different material selection. Could you kind of comment on that, please? And anybody can take the floor here.
Yeah, definitely. First of all, thank you for having us here. It's been a pleasure and an honor. It's no secret that this was a tough year for everybody, and especially us, given our failures that you mentioned. We had in January, well, I guess I'll take us back 2 years. Last Spaceport, we were going to do a dual stage rocket, and we had the whole design laid out. Come March, we paused for COVID. We came back in September and continued our design, continued all of our building, preparing to launch it, this week in New Mexico. And we continued that design up until about January. And we did a very basic test flight on the sustainer, just the top part of the rocket. And we were using an Aerotech M1350, I think. We had it sitting around for about a year, and there was actually a case failure on that motor. So we sent it back after the explosion. We sent it back to Aerotech, and we got the money back through their warranty program. That was kind of after the fact, because that incident destroyed about 80% of our sustainer.
Yeah,
put a pause.
That's bad news, right? It's tough.
It's very bad news.
So what was the failure? Can I ask? Yeah, what was the case problem?
So what we were able to determine was it overpressurized inside, and there were no grain defects from what we could see and what we could recover, but the actual laminations they use like kind of a wound fiber phenolic case. I'm sure you've flown these things.
Yes.
It was one of their disposable motor systems, and it delaminated. Somehow there was an air pocket or something in that fiber, and pressure got out the side, and that was really the end of it.
It's like a toilet paper. Yeah.
Yep. It actually shot the forward closure off the top. The forward closure was still secured to the case, and the case itself split in half and shot the forward closure up. Thankfully, we didn't have the payload in the rocket, because that would have destroyed the payload. We were flying a dummy payload, which is a 10-pound block of aluminum, and that was pretty well charred, obviously, because the motor was destroyed. But with respect to the engineering that we looked at after that, we obviously slowed down a little bit to look at where we were at. We were kind of at a pivot point, and we needed to decide whether to continue dual stage, drop out of the program. What we decided to do was take our booster section, which was still unharmed, and scale that up into a single stage rocket, which we've done in previous years. So we had a spare nose cone. We had just enough spare body tubes to make it work. So we really kind of switched into this value engineering mindset to design this thing, given the components that we had. We kind of had run out of our budget already. And so we said, what do we have here? How can we make this work? And how can we show up at this competition and be as competitive as possible? And it kind of turned it into an interesting design challenge, really, because typically we design with I'm obviously thinking about the money, but and what we have already in stock, but there's always this mindset of, oh, we can just get whatever we need and we'll make it work. Instead, we had a set amount of materials and we had to make it work from there.
What do you think about disposable motors now?
It's going to be a long time before I fly another one of those.
Yeah. I mean, these are the kind of lessons learned, that your pivot is actually a pretty amazing piece of work, and actually, if you ever get into business, you have to learn either to persevere or pivot. And most people have to pivot because most ventures fail at some particular point, right? So going through that experience, I imagine, has been kind of a learning experience for you, and maybe informs your longer term strategy in terms of where you're going next.
It really encouraged us as a team to continue to invest in our SRAD program, which we've had success with over the past 3 or 4 years. We also had an incident with our SRAD. We had I'm sure you saw in the paper, we had on the stand, one of our grains was defective due to poor QA/QC protocol on our part. And we realized that, that was terrible, but we've flown about 20 motors until that happened. And so our process for going through and building motors is really, I think, one of the strong points on this team. And it's something that I'm really proud of. And I think that kind of pushed us back towards that, to say, like, we don't want a failure on this team to be as a result of a commercial, something that we just purchased. If we're going to fail, it should be our own fault that we did something wrong. And at least we can learn something from that.
Right. Yeah, it's actually challenging to make your own motors, and anybody who's seen October Sky knows what vacuum buckets and motors will do for you, right?
Yes.
The other, let's see what else. I don't have actually too many questions. The overall, let me talk a little bit about the two-stage. So your motivation for doing two-stage in the first place, could you kind of describe what that was? Is it just the challenge of doing two-stage, and or was it from a mission perspective, you felt you needed to have a two-stage rocket to kind of loft your target payload to the target apogee, or what was the rationale there?
This goes back many years. It was actually supposed to be a two-year program where we started with a dual stage going to 10K, and we would eventually next year, or what would have been this year, dual stage to 30K.
Okay.
Because of our motor design and our propellant that we're really comfortable with, we need to get as long of a burn time as possible to stay under Mach. I mean, at competition, people hit Mach and they have problems, and we didn't want to be that team. We wanted to stay under Mach as much as possible with a 6-inch airframe. And apart from going to like a 5-inch motor or something, some sort of custom motor, we kind of had to go dual stage, and that was at least the easiest route that we picked to make that happen. And so that's why we did that. That was kind of the motivation, was the first step in a 2-step plan to get us to 30K.
So can you tell me a bit more about your fear of Mach? What kind of analysis or capability gaps do you have that are keeping you away from transmach?
I'm going to pass that over to Adam, who's done a lot of CFD on this.
Yeah, so it kind of harkens back to the fact that a lot of times when we see teams go past Mach, we see just fins fly off, which sends the rocket in a complete 90-degree angle, which we really don't like to see. And then there's also just the shock waves that form when you're going Mach that make things a lot less predictable, a lot more scary in general. Okay.
Yeah, I mean, I pushed a rocket to Mach 2.2 actually last year, and it was a minimum diameter project, and the nose cone imploded. When a nose cone, when you start gulping massive quantities of air at max Q, you're picking up the garbage. Is just the way it's all about. But the ability to kind of stretch yourself and push into these regions is actually, like, if you're going to 30K, yeah, you can do it nice, long, and slow. But you still have to get off the rail fast. So you're having to play with this game between max impulse motors and at some particular point. And if you're worried about fin flutter, for example, then maybe that's an area of analysis expertise that you can start thinking about developing over the next little bit, or looking harder at your kind of your FinCAN kind of design practices, right?
We actually this year, with all the time we had due to the COVID, we started looking more into doing CFD for our team. We started with some light CFD analysis of our 2-stage, and we're hoping to keep expanding that year after year after year, so that we can go do more of the things we were talking about.
Oh, excellent. Yeah. Let's see what else we got here. You know, I actually have very few questions for you. We've got a couple minutes left, because I've got a pretty good handle, I think, on what you've been doing, and obviously being nominated to the podium and to the payload presentations reflects the quality of the work that you've been doing. We've got like 1 or 2 minutes left. Do you have any questions that I can help you with?
I'm not sure we do at the moment. I think certainly just kind of building off of what we were talking about before, I think working into composites is certainly in the future of the team. We've had really good luck with purchasing commercial air fuselage, body tube sections, and working with that, obviously heavily modifying it based from that. But I think, just the amount of podium presentations on composites and all that stuff, it certainly is appealing for the future. We've had some tough times at the university getting all that through, but I do think it would be very interesting in the future.
Yeah, getting into the vacuum bagging and tip layup and all of that, that's actually a significant innovation step forward. And as you know, the competition actually really thrives on innovation, right? The teams that are innovating the most usually get rewarded the most. So just something to kind of keep in the back of your mind as you're considering next year. And meanwhile, I'd love to kind of catch one of your flights one of these days. So hopefully we'll stay in touch, and maybe I'll have a chance to do that.
Yeah, hopefully we'll be there next year. We'll see you.
All right. Well, thank you very much. Appreciate you taking the extra time this afternoon for my questions, and
thank you.
Have fun with the rest of the conference. Okay.
Thank you so much.
Yeah, sure. No problems.
Bye.
Thank you.
Thank you.